Hey everyone, I want to take an opportunity to talk about Bayes' theorem with you. We were all really excited when last year we didn't have to learn it, but that's come back to bite us in the butts a little bit because we do need it for our decision trees. So you're hopefully familiar with our conditional probabilities, where we're dealing with a probability that's only true because we're in some scenario. And so this notation of the probability of B given A means that B is happening, or the probability that B is happening, given that we know A is already has happened. So when we're looking at Bayes' theorem, this is really an application of switching the order of our trees. So if I have a tree that's defined as being A and then not A, followed by the event B, whatever scenario is happening, whatever A and B happen to represent in this problem, what we do know is that the probability that would go on this branch here is the probability that B is occurring given A happened. This is great, but what if we're not given information in this order, right? What if the information that we've been given works in the other direction? So what if I've got the probability, what if instead the information is being presented as B occurring first and then A happening? So in this situation here, our probability on these branches is the probability of A given that we know B has happened, the probability of not A given that we know B has happened, probability of A given not B, and the probability of not A given not B. You're like, oh God, Dalton, what do all these things mean? I promise it comes together when we start looking at this in the context of an actual practice problem. But before we jump to that, it's important to recognize that we have a really powerful formula, and that is the Bayes theorem. So Bayes theorem allows us to go from basically one direction to a different direction. So whichever direction we've been given things, we can always get it into the other one if we've been given enough information. So when we're looking at the formula here, the probability of A given B times B, this is simply going to be us taking our two branches, so the probability, whatever probability we have of B occurring, times the probability of A given B. So these two branches, that's what's happening on the top here. On the bottom, you're like, oh God, it's such a big, scary formula. But what we're saying here is that we have the probability of simply A occurring. So anytime we're working with Bayes' theorem, whatever the given is, okay, that probability has to go on the bottom. So these two formulas are actually equivalent. So the probability of A is equal to the probability of A given B times the probability of B, the probability of A given not B times the probability of not B. Again, big formula, but what we're really doing there is multiplying the two sets of branches that contain A. So we'd be multiplying these two here and these two here and adding them up, okay? And that's going to give us the probability of A, which is just what that denominator is. And that's usually how I start a tree, because I'm going to want to know, well, what's the probability of A, that first branch, when I go to build my tree in the opposite direction, okay? So this is all well said and done, but let's take a look at an example to put this into effect. So here I have an example where we have a side effect. So the probability of having a side effect for a new drug is 10% if you are female, okay? So as soon as I see that, I'm like, oh, that is a conditional probability. This is telling us that if I'm female, the probability of having a side effect is 10%. The probability of not having a side effect if you are male is 95%. If 40% of the study was female, what's the probability that someone with a side effect is male. So we're existing in a gender binary world here, like a lot of problems. Just an example though, not real life. And the main thing here is that we want to recognize that there are two different events happening. The two different events, basically the A and the B, the two sets of branches here, we basically have your female or not female, and we could refer to that as just being male, okay, in the context of this problem. The other event that's happening is that you can have a side effect or no side effect. Now, the direction of this tree as it currently stands is that we've been given the probability of getting a side effect conditioned on whether or not we're male or female. So whether or not we're male or female is the thing that's going to come first. And you don't have to use trees to solve these. You can go straight to the probabilities. I find it makes a lot more sense to just put our probabilities onto a tree, take the extra minute to draw a tree, and then go from there. So I'm going to call the upper branch being female, and then male. And then the second event here is whether or not we have a side effect. So we can have a side effect or we can have no side effect. I'm just going to use some shorthand here so that we don't have a super messy tree. Okay, and this isn't a full-blown decision tree. We don't have payoffs or anything like that. We're just working with the probabilities to reverse them. When you're doing this in the context of decision trees, well, you're going to have a lot of other stuff happening. It's really just, you're going to step to the side, deal with your Bayes, get the probabilities that you want, and then go back to the problem. So in this situation, looking at the information I'm getting given, it told me that 40% was female. So I have 40% here, and if I know that's 40%, I automatically know that I've got 60% there. The probability of having a side effect if you are female, so again, I'm down this branch, I'm having a side effect, is 10%. So I've got 10% here, and that automatically tells me that the probability of no side effect is going to be 90. And the probability of not having a side effect if you're male is 95%. So I've got 95% here, which means this is going to be 5%. So then it asks us, well, what is the probability that someone with a side effect is male? So with a side effect is male is saying that we're looking for the probability that someone is male given we know they had a side effect. So the side effect becomes the given information. What I want to be able to do in this situation is draw the tree backwards, which is basically the point of Bayes, okay? So I want to be able to know, did someone have a side effect or not? What's the chance? And then, based on whether or not they had a side effect, are they male or are they female? Oh, and guys, I just realized that I was going with wording of the problem here and I put male first and then female, and here I had female and then male. Hopefully that won't mess you up. I've just flipped the order there by accident. It doesn't actually matter which one we put on the top or the bottom. So in order to basically get the probabilities for this tree, I mean, we are looking for the probability that goes on this branch. That's the goal here. In order to get that probability, I'm always going to need to know the probability of the branch before it. And that's the whole point of Bayes. When we look at Bayes' theorem, in order to reverse, in order to go from A given B to B given A, I need this denominator that's really just the probability of whatever the given situation is. So in this case, the given situation that we're looking for is the probability of having a side effect. So I'm going to go ahead and I'm going to solve for that first. I can do it within the context of my Bayes theorem, but on most things, we're going to actually have to solve for multiple points. So it's good to just have it in general. So our probability of having a side effect, remember I told you the probability of getting anything there is really just going to be us adding up the appropriate branches. So if we look at our original tree, our branches here, we've got 2 that have side effects, and we're going to multiply those 2 sets and add them together. Formally, what we're doing is we want to take the probability of having a side effect given being female, and we want to multiply it by the probability of being female. Then we want to take the probability of having a side effect given not being female. So in this case, I'm just going to call that male, because that's the more intuitive notation we're using right now. And I'm going to populate that. So my probability of having a side effect given that I'm female, that's that 10% there. Probability of being female, that was 40%. The probability of having a side effect given that I'm male, well, that's this branch here, so my 5%. And then the probability of being male is 60. And so if I calculate this is going to come back, and this is going to give me the probability of having a side effect as 0.065. Seems like a big scary formula, but all we're really doing, guys, is I wanted the probability of a side effect. So any of the sets of branches that had side effect, I multiplied and added together. So I took that first branch there, and then I took the second set of branches. That's all we're doing there to get that answer. So now that I have that, I'm just going to put it on my tree just so I've got it. You don't have to put everything on your tree if you don't want to, but I really like to make sure that I know what's happening. And if this probability of a side effect is 6.5%, I automatically know, I might not need it, but in other problems I definitely just need my whole tree, that this is going to be 93.5% here. They always have to add up to 1. So now that I have this, I can figure out my probability of being male given I have a side effect. So going back to my Bayes theorem, the top here, okay, I've already found the bottom. It's just going to go in the opposite direction and then times whatever the second term was. What is this practically speaking? I have male, I want male given that I know that they have a side effect. I basically want to take that branch from the other tree that's going in the wrong direction, not what we want, and I want to divide it by my total probability. So my formal notation here is going to be the probability of having a side effect given that we're male times the probability of being male over the probability of having a side effect. Whatever the second term here is, that goes on the bottom. These 2 terms always match. But practically speaking, I'm like, okay, I want side effect and male. I want this combo. So I go back to my original problem and I'm multiplying those together. So I've got 0.05 times 0.6. So my probability of having that side effect given I'm male times chance I'm male, which is 60%. And I'm dividing that by that total chance that I just might have a side effect, which is 0.65. 0.065. Don't make that mistake. Oh my goodness, that would not be good. And so my actual probability here is going to be 0.4615. So in this situation, right, the probability goes here 0.4615. So the probability that someone with a side effect is male, well, that's going to be 0.4615 or 46.15%. Okay? And so I don't think that Bayes becomes that difficult once we draw it out. The trickiest part of it by far is reading and interpreting the question, okay? And being able to draw those original trees. So in the context of BDM, we are going to do this Bayes theorem in a lot when it comes to the market research. So if we are trying to figure out the impact of market research, sometimes it gets given to us in the wrong direction. So here I have, if the market is strong, there's an 80% chance that the research would have indicated so. If the market was weak, there was a 90% chance that the research would have indicated so. We know there's currently a 30% chance that the market will be weak. Now, I realize that this is really simple wording in the grand scheme compared to other things, but we want to recognize that no matter how difficult the wording might be, it's really just about breaking down what they're giving us into a sentence like this that makes sense to you. So as you're working through the problems, jot down what makes sense to you and then come back to build your tree. So the major issue here is that they've told us the accuracy of the research based off of the condition of the market. So what we have here is that they're telling us, well, if we know that the market is strong, then we can tell you that there's an 80% chance that the research would have told us that. And so our research result comes after we know whether the market is strong or weak, okay? And so just for our sanity, 80% chance that the research would have indicated. So I'm going to indicate that as being the research can either come out positive or negative. Basically, positive meaning the research telling us that it was supposed to be strong, and negative meaning that it told us that it was going to be, that it ended up being weak, or it's going to tell us that it's going to be weak. Just so that we're not conflating that with the actual state of the market. So we've got positive and negative. Now, anytime you are doing sampling information in the context of decision trees, you need the result to come first, right? You're going to get the result from the marketing firm and then do the analysis of whether or not you want to, pursue the product or the, whatever's going on in the problem. This, what I'm drawing here, is not your decision tree. This is simply me getting the probabilities that I need to go on that decision tree. Because what's going to happen is in your decision tree, after you get the positive or the negative or however that market research is being presented to you, after you get the information, you're going to have a decision about how you want to respond to that information. And later on in that decision, you're going to use these probabilities that we're finding right now about whether or not things are strong or weak, diseased or not, or whatever's going on in the problem. This right here is just us figuring out what we're going to do in terms of getting those probabilities. So I can have strong, weak. This time I didn't mix up the order for you. Strong and weak, okay? So in the context of our sampling information, we always need it to be the market results, the marketing results, market research results, whatever you want to call it. And then the state of the market or the game or whatever's going on, okay? But we always want the research first. But in this situation, we're not given it in that regard. So this is telling us that if the market is strong, there's an 80% chance that the research would have indicated so. That's telling us that this branch here, positive, was 80%. So we know that this is 20%. If the market research was weak, there's a 90% chance that the research would have indicated so. So if it was weak, there's a 90% chance that the research would have come back negative, so only 10% positive. Strong versus weak, 30% chance that the market will be weak. I originally had that at 20, but then I realized this was 80-20 and I didn't want to have numbers that you could get confused on. So this 30% chance that the market will be weak goes here, and I automatically know then that the probability of being strong is 70%. So when we're working on this, you'll notice that I just like popped in all those other probabilities. When we're working in the tree, it makes it really easy to see what those probabilities are going to be instead of just writing everything out by hand. So in this scenario, again, we're trying to reverse. Like in the last problem, figuring out the probability of it just being positive or just being negative is your first go-to. So I'm going to choose positive. It actually doesn't matter which one of these you select. And so my probability of getting a positive result is again the combination of the branches that contain positive from the original tree. So with proper notation, that's the probability of a positive result given that the economy was strong times the probability that the economy was strong plus the probability of a positive result given a weak economy times the probability of weak. All of that, and so that is just me applying the denominator of Bayes' theory, the fact that I know that this formula here is equal to simply the probability of A. But practically speaking, what am I doing? I'm just multiplying those branches together and adding them up. So the probability of it being positive given strong, that's 80%. And the chance that I'm in a strong economy is 70%, plus probability that it's positive given that we had weak was 30%, and then the probability, was 10%, and then the next one here, the probability of it being weak is 30%, okay? And so if I calculate this, it's going to give me a probability here of 0.59 or 59%. So I know that on my chart here, my new tree here, that says 59. I automatically know that the probability of being negative then is going to be 41. So now that I have that, it's about getting the other branches here. So if I want the probability that the economy is strong, given that we're in a positive, that we had positive research, well, I can use my Bayes formula because I've already figured out that denominator. I don't need to go through the big part here. And remember, it's just flipped from whatever we're looking for. So here, I'm going to use the probability of it being positive, given that it's strong, times the probability that the economy was strong, over the probability that the results came out positive. What is this really saying? This is simply telling me that I'm going to take, I'm looking for positive and strong. So I'm going to take the branches of strong and positive from the other tree, multiply them together, and divide by my total over here. So whatever's in that second position, whatever we're conditioning on, goes in the bottom. We're dividing by that probability. So here I've got probability of positive given strong. That's just my 80%. So 0.8 times 0.7, because that's the chance I'm even strong, divided by 0.59. And if I calculate this, this is going to come out and it's going to give me a probability of 0.95. So I know my probability here is 0.95, which means I automatically know that the chance that the economy is weak, if my research comes out positive, is just going to be 5%. You only have to find one of the branches, and then you just use one minus the other one to get your answer there. So if I wanted now the probability of it being strong, given we had negative research, so now I'm looking for the probability of strong given that it's negative. And let me, again, it doesn't matter. I could have done weak given negative. I can look for either one of these, okay? If I write out my formula, if I'm sticking with a formulaic approach here, I'm going to go backwards. So it's going to be the probability of a negative result given a strong economy, and then I multiply on that top by whatever the second term was. So here it's strong, and then I'm going to divide by the probability of that second term. These will never be the same. If you find yourself putting strong on top and strong on the bottom, you've made a mistake there, right? Because that would just cancel out, and we wouldn't actually be doing a calculation. So, again, looking at our trees, if I want negative and strong, like that's what I'm looking for here, I'm just trying to switch the direction that we had going on over here. All we need to do is basically switch the order of these branches, and by doing that, we're going to take, so here I'm looking for that probability of being strong given negative. I'm going to look for that set of branch along the tree, our original tree, so I've got strong and negative here. These two are being multiplied on top, and I'm going to divide by my first branch. So my probability of the results being negative given I had a strong economy was 20%. Probability of even having a strong economy is 70%. And the probability of the research coming out negative, well, we had found that before, and that's 0.41. Okay? And so if I calculate this out, it's going to give me a probability of 0.659, and I can put that right on my chart. I've got 0.659, and then my resulting probability here is just 1 minus, right? So it's going to be 0.341. So whenever we're doing a decision tree that is related to, figuring, like having some kind of sampling information, some kind of survey, some kind of market data, we do have to check that we've been given the information in the right way. Has it told us the chance that the economy is going to be strong or the situation is going to be good based off of the research? Or has it told you the results of the research based off of the state of the economy or the situation that's going on? If it's the latter, you're going to have to use Bayes to switch it into the right direction. Again, this is not a decision tree that would end up in your decision tree for the actual problem in that situation. These are just to help us work with Bayes' theorem. Whenever we're working with decision making and we have survey information, after our survey results, whether they came out good or bad, there's always going to be a decision about what we want to do to act on those results, okay? If you have any questions, feel free to email me or Facebook me, but hopefully that gives you a little bit of clarity into Bayes as you apply it to your assignments and your homework. Have a great day, guys.